All right, so this is part 2, talking about the last quadrilateral that we'll learn, the kite. Okay, so a kite is a quadrilateral with exactly 2 pairs of consecutive, remember consecutive means next to, not opposite, congruent sides. So we don't have opposite congruent sides, we have consecutive congruent sides. However, the opposite sides are not congruent or parallel. Okay, so this is nothing like a parallelogram. All right, so here are the properties of a kite. We have 2 pairs of adjacent sides that are congruent. So adjacent means consecutive, right? Next to. AB is congruent to side AD. And then BC is congruent to side DC. Okay. 1 pair of opposite angles is congruent. All right, so this is what, the figure looks a little confusing, right? It's got a lot going on. There's 1 pair of opposite angles that are congruent, and it's always on the shorter diagonal. Okay, the shorter diagonal has the pair of opposite angles that are congruent. Angle B from this figure is congruent to angle D. Okay, that's my pair of opposite sides that are congruent. A and C are not congruent. Okay, diagonals are perpendicular to each other, so I have 4 right angles at the intersection of my diagonals. And the longer diagonal bisects the shorter one. So the diagonals aren't bisecting each other, but this longer diagonal is bisecting the shorter one. Okay, so there's a few things going on the short diagonal. The short diagonal has the pair of opposite angles that are congruent, and the short diagonal is getting cut in half. Okay, one property that's not listed on here that you will need to know is that the longer diagonal, so the long diagonal, bisects its opposite angles. Okay, so I must put bisects its angles. So the angles A and C on this long diagonal are not congruent to each other, but they are getting bisected by this long diagonal. So we got to remember this. Here are the opposite congruent angles that are not bisected. Here are the opposite angles that are not congruent, but they are bisected. Okay, and the way to think about this is that we have created 2 isosceles triangles, one on this side, one on this side. Remember isosceles triangles, if I kind of look at just this first one, here are my 2 congruent legs, here are my 2 congruent base angles. Okay, and then the vertex angle, if I were to drop down an altitude, would bisect that vertex angle. And then same thing over here. Here's an isosceles triangle, my 2 congruent legs, my 2 congruent base angles. Vertex angle is getting bisected by this altitude. Okay, so this one is a little bit more confusing. Okay, but we do have 1 pair of opposite congruent angles. These are not congruent as A and C, but they are bisected. Okay, so with that, let's look at the examples. If LMNO is a kite, find X. Okay, kites have 90-degree angles at the diagonals, right? Diagonals are perpendicular. We know on the long diagonal that even though L is not congruent to N, they are both bisected. So 32, 32. I can solve for X by looking at this right triangle right here. 90 plus 32 plus X forms a triangle which is equal to 180. Okay, so I'm essentially taking 180 minus 90 minus 32. X is equal to 58 degrees. If EFGH is a kite, find the measure of angle 1 and angle 2. Okay, if I drew in my diagonals, remember the longer diagonals, these angles are not congruent, but the ones on the shorter diagonal are congruent. So angle H is congruent, or angle 1 is congruent to angle 2. That's the 1 pair of opposite congruent angles. A kite is still a quadrilateral, right? It's still 360 degrees for all four angles. So if I subtract the 102 and the 48, that's going to get me what's remaining, angles 1 and 2. And these two angles are congruent. So to figure out their measure, divide them by 2. Okay? So 360 minus 102 minus 48, that gets me 210. Divide that by 2, and each angle is equal to 105 degrees. Both angles 1 and angle 2 would be equal to 105. Okay. Number 7, if GHJK is a kite, RJ is equal to 9. Remember, the shorter diagonal gets bisected by the longer, so GR is also 9. Here's right angles. RK is 12. Find JK. I'm going to put an X right there. Because we have right angles at our diagonal, and they've given me RJ and RK, here's a right triangle. I can use Pythagorean theorem. 9 squared plus 12 squared is equal to x squared, which would be the side that I'm missing. 81 plus 144 is equal to x squared. When I combine 81 plus 144, I get 225, and then I take the square root. That means that JK is equal to 15. And number 8, last one. If ABCD is a kite, find X and Y. So this is all on the sides. We have consecutive congruent sides, meaning AB and BC are congruent. 3x plus 12 is equal to 5x. If I subtract over 3x, 12 is equal to 2x. Divide by 2, x is equal to 6. And then over here, AD is congruent to CD, so 11y minus 22 is equal to 7y minus 6. Subtract over 7y. 4y minus 22 is equal to negative 6. Add over 22. 4y would be equal to 16. Divide by 4. Y is equal to 4.